G prime is what? Positive or negative?
G prime is negative.
Negative, which means G starts out somewhere and immediately starts decreasing, right? G prime is negative, G is decreasing. That means at -3, that's a maximum for G, because it started somewhere and immediately started going downward, which means it starts at a high point. So G has a relative maximum at -3. Now it keeps going downward, G keeps going downward until we get to -2.5. At that point, G prime is 0, which means G starts turning, right? G comes easy to turn if we switch over. Did we switch over?
Yeah.
Yes. G prime was negative, then becomes 0, then positive, which means G is decreasing, then turns, then increasing. Decreasing, then turns, and increasing. That's a local.
It's a minimum.
A minimum. Here's a mimic of it. Decreasing, then turns, and increasing.
Right.
When a graph decreases, then turns and increases, that's a local min.
Yeah.
So G has a local min when x is equal to -2.5, because G prime is negative and then becomes 0, then becomes positive, indicating that G is decreasing, then turns, then increases. Next critical number for G is here, because that's the next place where G prime is 0. Well, at 0, G has a relative maximum, right? Here's why. G was increasing before 0, then decreasing after 0, because G prime was positive before 0, then becomes 0 at 0, then positive, then negative, right? Which means G is increasing before 0, turns, and then decreasing. Increasing, turns, decreasing, that's an over the hill type of deal. Maximum. Please note again, this is G prime. So therefore, you are saying, because G prime is positive, G is increasing. Then G prime is 0, so G is turning, or attempting to turn. And then G prime is negative, therefore G is decreasing. So G was increasing, then turns and decreases, that's a max. Are you with me so far? It's a relative maximum. G has a relative maximum at x equal to 0. Then at 2, it's the same thing that happened at -2. See? Same deal.
Yeah.
G is decreasing. G prime is negative. So G is decreasing. Then G turns because G prime is 0. And then G increases because G prime is positive.
Local minimum.
Right. Decrease, increase. Next place is right here. At this point, it's a little trickier because it's where the graph ends. But before 4, to the left of 4, when x is less than 4, G prime is positive, which means G was increasing and then it stopped. Which means it stops at a high point, which means that's a maximum.
Right.
All of these sections here are answers to part A. And they're all based on this note. The note says when G prime is negative, G is decreasing. When G prime is positive, G is increasing. And when G prime is equal to 0, G has a critical number. Critical number is a point where the graph possibly has a maximum on it.
Oh, negative.
Negative 2.5 is the minimum. And 2. Are you with me? Negative 2.5. Now we're going to go over to part B. Determine where graph is concave, up and down and down. Actually, for part C, we're not ready for that yet because that involves a little bit of area.
So for A, you have 4 parts to that answer.
Yes, because there are 1, 2, 3, 4. We have 5 parts actually. 1, 2. But part, this part here, I said 2 things at the same time because the same thing happened at negative 2.5. Haven't got 2.
2 is a minimum?
Oh.
2 is a maximum?
Negative 2.5 is a minimum. And
Oh,
negative
2.
and 2 is a, oh, I should change that. Thank you for catching that, man. It's a minimum for the same reason that it was at 2.5. So I kept saying the right thing and doing the wrong thing. So, there are 4 things places that it happens. At negative 3, negative 2.5, 0, 2, and 4, right? It It only looks like 4 degrees because the same thing that happened at negative 2.5 happened at 2. So we just combine them as, hey, same thing happened. The same thing happened here. So it's 1, 2, 3, 4, 5.
Okay.
And well, we were just saying what happened at negative 2.5 also happened at
2.
2. It's clicking on. It's gonna be forgotten after this, and let's go back and
That's true.
pour over similar type of questions. Now part B. Now we're doing part B. We're asking, determine the values of f where g has a relative max. Sorry, where g has is concave down and concave up, right? So I'm gonna change my note a bit. Because I have the first note, part of the note already. And let's see what it says now. The note says, I'm going to try to fix this. F is increasing. F g prime is increasing, so when g prime is increasing, g double prime is greater than 0. So g is concave up. When g prime is decreasing, g double prime is slowing down again.
It's less than 0.
Yes, but my computer is frozen, so I'm waiting. It sometimes saves the graph. Last time when I was teaching my other calculus class, it just crashed.
So did you lost all of your data?
No, it's just restarted the computer.
It happened to me on my phone last night and I lost all of my data in the phone.
That's painful.
52 gig.
Since this morning.
I tend to back up my data periodically.
You won't know.
So I don't lose too much.
I have a life.
But I still have to back up
You
my
understand.
contacts. So here's the note that we're going to use to answer the next question, part B. I'm going to erase that stuff there. Now we're going to ask about about concavity of G, right? We want to find out when G is concave up and when G is concave downward. So we're going to answer that in a minute. But the note says, when G prime is increasing, that means G double prime, which is the derivative of G prime,
Positive.
is positive. When G double prime is positive, G is what?
Increasing.
No, concave up. That's why you have to do 15, 15, 30, because you have to know these things, right? When G prime is increasing, G double prime is positive. That means that that same interval, G is concave up. When G prime is decreasing, G double prime is negative, which means G is concave downward. And when G prime again is increasing, same thing, right? When G prime is turning, it's changing direction. Changing from increasing to decreasing or decreasing to increasing. Those are places where G prime, double prime is 0. Which means we have points of inflection for G. Because now G is changing from concave up to concave down, or from concave down to concave up. Why? Because G prime is changing from increasing to decreasing, and G prime is changing from decreasing to increasing. Therefore, my possible points of inflection occur at -1. Where else? 1 and 3. Because those are places where G prime is turning. When G prime is turning, those are possible inflection points for G. Because those are places where G double prime is 0. Now, they're asking for concavity. Concavity occurs between inflection points. So we're going to first identify our inflection points. Inflection points occur at what places again?
And 0.
No.
What?
Inflection points occur at what points? Inflection points of G occur where on this graph?
Where is concave?
Where it's turning, right?
Where G prime is turning. Where is G prime turning?
Man.
-1,
It's in the middle.
1, and 3. So those are my only places to check inflection points. When G prime is turning, G has possible inflection. Because that's where G double prime is 0. Alright, so let's indicate those right now.
Whatever you erased a moment ago, was that posted still?
Oh yeah, that's on the previous page.
Okay.
Let me show you.
Yes.
See?
Oh, thank you.
I just copied it, I duplicated the page. So, inflection.
Even though,
points.
last class he was teaching us some important stuff for 15 minutes. The video I have taken, it also gone.
It was on the video you
Yeah,
made.
everything gone. I told you everything.
Back it up to your cloud, dude.
I don't have an iPhone.
You were saying you lost that video.
Yeah.
I can
What's the
send you
inflection
it.
points of G
Huh?
I can probably
occur
send it to you. I have it
when
still.
G prime is turning? So, inflection
It's gonna be hard to send a 15-minute video.
are
Unless by
at
email,
x
maybe.
equal
Email
I
would
have
be
to zip it,
negative 1,
and you gotta unzip it.
x equal to,
Google Drive.
Oh, okay.
x equal to what? 1.
YouTube.
And x equal to, where else?
Oh, yeah. We got -1.
Oh, 3?
3. Alright. G is concave up. When is G concave up?
When G prime is increasing.
Right, so when is G prime increasing? Starts increasing at -3, right? Yes?
Yep. Yes.
Yeah.
And then G prime goes above -3 and goes positive.
Right, when does G prime stop increasing though?
At the turn.
When does it turn?
-1.
Alright, so G prime is increasing at from -3 to -1. Anywhere else?
From 1, 3.
Uh-huh. That's correct. These are intervals, by the way.
Yeah.
Intervals of x values. And then G is concave down on which intervals?
From -1 to 1.
From -1 to 1. Why is that?
-1 to 1?
No, not negative 1
I
to
thought
1.
it was going to be like -2.5
Yep, -1
0,
to 1.
something like that.
Anywhere else?
Wait, negative, no. Negative 2.5 to 1.
No. Think again. Why is it -1 to 1?
Because you're starting off, when you follow -1, right?
Yep.
You start up at the top,
Uh-huh.
and then you start decreasing,
Yes.
and then you end up, and then it stops. It gets to 0 at 1 again.
Yep. The graph of G prime. G prime starts decreasing when x is -1, right? And stops decreasing at 1. Which means G is concave down when x is from -1 to 1. Because that's exactly the place where G double prime is negative. When G double prime is negative, G is concave down, right? Right? But when G is concave, how do we know when how do we know when G double prime is negative? That's when G prime is decreasing. So whenever G prime is decreasing, G is concave down. And whenever G prime is increasing, G is concave up. One last thing I want to show you, and then we are going to take a break and then do optimization. All right. I want to draw a little sketch underneath here to represent what happens. I'm going to actually take this graph. I'm going to do a sketch around it to represent what's happening with f prime and f double prime. Right?
Yeah.
And then we'll use that to represent what's going, not f star G. I'm going to use that to represent what's going on with
I thought I was recording, man.
with G.
You gotta be kidding me. I wasn't recording. Oh my
Right.
goodness.
That sucks.
Oh, I'm just running out of room, maybe. It's stopping my
I was wondering,
videos.
how much power do you have? How much room do you have on that phone, man? You can record for so long.
Well, 3 hours?
Goodness.
Golly.
No, I started when he started analysis. Oh, this is bad.
Oh my god.
Look, what does this mean? Why does it do that?
Because you have no more space, bro.
Oh my.
It's making sense.
You better buy some space on Google Drive.
You better start deleting stuff. Why don't you do this, bro? Check this out. Hey, bro.
Oh my goodness.
You have a Facebook account?
Yeah.
Okay. Live streaming.
Live stream.
And not only you can see it.
Yeah.
Oh.
I
But it
mean,
won't
you
be
can
as,
set it up. No, I wait.
but it won't be as clear though as me.
So,
I have it.
nothing.
I have it. I have it though.
Alright, cool.
I-
So, what I'm going to do.
I have it.
You gotta give me your number. What's your number, bro?
863.
You guys
Six, seven,
that's going to be
seven.
a big file to change, to transfer. You're going to have to put it on a cloud service and just share it.
8019, yeah.
Eight.
Google Drive or YouTube?
863
Oh, yeah, you can upload
677.
it to the folder.
677
8019.
8019. Ash.
All right, now, what I'm going to do now is do a first derivative test type of deal with this graph. So I'm going to use the same graph here, and I'm going to just do a mimicking of what's going on the axis. So, watch what's going on here. On this little line here, I'm going to show what the graph of G is doing. Are you with me?
Mm-hmm.
All right, now, the numbers in question are 0, -1, -2.5, -3, 1, 2, 3, and 4. Now, since I'm only talking about G prime, I'm going to eliminate the parts that only refer to the concavity. So I'm going to eliminate -1, because -1 is a turning point for G prime. That's an inflection point for G. I don't need that for what I'm going to do right here. And I'm going to eliminate 1 as well for the same reason. And I'm also going to eliminate 3 for the same reason. So the question is, what is the process that G is going through from here to here? All right. First of all, G starts here and then decreases. Then at -2.5, G turns. Why does G turn? Because G prime is 0. Are you with me? Are you with me, folks? At -2.5, G prime is 0, but at -3, G prime is negative. Are you with me?
Mm-hmm.
Then, from -2.5 to 0, what is the value of G prime? A positive or a negative?
From -2. Oh, it's a positive.
Positive, which means G is doing what? Increasing. This is what the graph of G looks like. These are just what a rough sketch of the graph. And then what's happening at 0? What is G doing at 0?
I know G prime is turning.
Right. No, G prime isn't turning at 0. G prime is 0 at 0.
Oh.
So at 0, G prime is 0. That means G is turning, right? Yes?
Yeah.
And then G starts decreasing again till we get to 2. And then what's happening at 2?
G prime is 0.
G prime is 0 again. That means G is turning. By the way, right here, G prime is negative because it's below the x-axis. The graph is below the x-axis. Now, what is G prime from 2 to 4? Positive or negative? G prime from 2 to 4.
Positive.
Positive, it's above the x-axis, right?
Mm-hmm.
Therefore, what is G doing from 2 to 4?
Increasing.
And that's how we got those max and min. Max, min, max, min, max.
Kind of tricky.
Yes, more than kind of. Now, same concept for concavity. All right? So I'm going to go up here and I'm going to do concavity. First, I'm going to remove this guy because I don't need it for this question. And I'm going to draw a line now, but this line is about concavity. This one is trickier than the other one before because we have to get the information from analyzing the graph. This is the graph of G double prime, all right? The points in question are at wherever G prime is turning. So we're talking about at -1, at 1, and where does it turn? Where does G prime turn? At 3.
3.
Now G double prime is, when G prime is increasing, G double prime is positive, right? Because the derivative
Yes.
of G prime. When G prime is decreasing, G double prime is negative, right?
Yes.
When G prime is turning, G double prime is 0. So we're talking about another positive between here because G prime is increasing from 1 to 3, and then from 3 to 4, right?
Negative.
G prime is negative. G double prime is negative, which means from 4 to -1. I should put this up here. From 4 to -1, G is concave. G is concave up because G prime is positive. And then from -1 to 0, G is concave down.
This way, right? Concave down is this.
No. When it opens upward, that's concave up. When it opens downward, that's concave down.
Okay.
And then this is concave up. And then right here, it's going to be concave down. And you'll see that it goes along with what we analyzed before. That's that for that question. We're going to pause here and take a 10-minute break.
Okay.
And then we will come back to